I'm going to show you how to find the derivatives of, well, the harder exponential functions and logarithmic functions, or at least where those rules come from. I hope by now, or maybe I'll just tell you, the derivative of e to the x is its own function, or the derivative of e to the x is e to the x. E to the x is its own derivative. These are in the wrong order. We're going to find the derivative of exponential functions of all bases first, and then we're going to find the derivative of logarithmic functions of all bases. I'm not going to do a bunch of examples, except for the examples that try to help prove the rule. A common technique is to rearrange functions from something you can't do into something you can do. For example, a lot of people forget what the derivative formula for inverse sine is. So something you can do instead is, take sine of both sides, use implicit differentiation, and find the derivative that way. You go from, hey, I don't know how to find the derivative of inverse sine to, oh yeah, the derivative of sine is cosine, and with implicit differentiation, hey, no problem. We're going to use a very similar idea here. So let's say you didn't know what the derivative of natural log is. Well, you could exponentiate both sides as powers of e. E to the power natural log of x is x, and on the left-hand side, all we have to worry about is e to the power of y. Well, the derivative of e to something is e to that same power, and chain rule, or implicit differentiation, dy dx, and the derivative of x is 1. So, we need a different color red. So that means the derivative of natural log of x is 1 over e to the y. Well, that seems strange to have the derivative of natural log of x involving y, so let's rearrange. Where's e to the y? Oh, there it is. So the derivative of natural log of x, replace e to the y with x. The derivative of natural log of x is x. And natural log is a pretty common function. That's one you should memorize. Although notice, if you forget, hey, you can rearrange. So with that in mind, hey, the derivative of natural log of x is 1 over x, or the derivative of natural log is 1 over the input. We can just say, hey, dy dx, the derivative of natural log of 3x is 1 over that input, 3x. Chain rule times 3. So the derivative of natural log of x is actually just 1 over x. Let's use that derivative rule here. Hopefully you notice the structure. X natural log of x is a product of two functions, and the derivative of the product of two functions is the first function times the derivative of the second function plus the second function times the derivative of the first. And of course, we'll just rearrange that pretty easily to get 1 plus natural log of x. What could we do here? The derivative of a quotient of two functions is the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all over the denominator squared. We don't get a ton of simplification. Natural log of x minus 1 over natural log of x squared is all we can do. Alright, well, this is a different derivative rule. Let's assume you don't know or want to know where this rule comes from. Logarithms allow you to play with exponents. So natural log of both sides. Why would we use natural log even though this base is 2? Because, well, the derivative of natural log we know. So we only want to use things we know here. So, what does that allow us to do? Natural log of y is equal to x times the natural log of 2. The logarithm allows us to take the exponent, move it out front to be the coefficient of the log, well, the exponent of what is inside the logarithm. Anyways, so the right-hand side, as I now see it, natural log of 2, you may not know exactly what that is, but that represents some constant. So the right-hand side is actually really easy to take the derivative of, since the derivative of a constant times a function is that constant times the derivative of that function. And on the left-hand side, natural log of y. Let's see, the derivative of natural log is 1 over the input, and that input is y, so we need chain rule or implicit differentiation, dy dx. And so, what do we get? We get 1 over, I need to multiply both sides by y, and I will get y natural log of 2, and can we get rid of that y? How about blue? We sure can. What can I replace y with? Oh yeah, what I started with, 2 to the power of x. Cool. All right, let's see if we can find a pattern. Start with red again. So I don't know the derivative of 3 to the power x, but the derivative of e to the power x is e to the x. The derivative of 2 to the power x is 2 to the power x. Natural log of 2. Maybe I have an idea. So we'll take natural log of both sides, which allows, on the right-hand side, me to move that x out front of the natural log. And natural log of 3 is a constant. So on the right-hand side, the derivative of a constant times a function is that constant times the derivative of that function. And the derivative of natural log is 1 over the input. The input is y, so chain rule dy dx. And what dy dx? Multiply both sides by y is y natural log of 3. And what is y equal to? Oh yeah, y is equal to 3 to the power x. So is there a pattern here? Let's see. The derivative of e to the x is e to the x. The derivative of 2 to the x is 2 to the x natural log of 2. The derivative of 3 to the x is 3 to the x natural log of 3. Maybe we can go back. Does this work? The derivative of e to the x is e to the x natural log of e. Yeah, natural log of e is 1. So that rule does work. Let's see if we can prove that. One more time. So let's go a little quicker. Natural log of y is equal to, well, I'm going to take natural log of 4 to the power x and end up with x natural log of 4. 1 over y dy dx, when I take a derivative, is equal to 1 times the natural log of 4. And dy dx is equal to, maybe I'll multiply this side by y and this side by what y is equal to. Okay, so I feel like there's a pattern. Let's see if we can prove it now. So a is any constant. Well, for which a is an allowable base. So let's just say any constant greater than 0. So we'll take natural log of both sides. And it really doesn't matter, as you saw, what a is, so long as a is a positive constant. We can move that exponent up front, and natural log of a, we don't know what constant that is equal to, but we know it is equal to some number. So easy derivatives, or at least the ones we've been doing. And dy dx, so here I'll multiply by y, here I'll multiply by what y is equal to. Okay, so any exponential function has the derivative of like itself natural log of the base. What about logarithms? Well, there are two ways to get rid of the logarithm. Again, we're trying to figure out where these things come from. So what would the two ways be? Well, I would say the easiest way, maybe let's write that on a new line. The inverse of log base 2 is 2 to the power. So 2 to the power y is equal to x, and now if you know, hey, the derivative of 2 to the power is 2 to that same power, natural log of 2. Chain rule in this case, because the input is y, and the derivative of x is 1. Doesn't look like a y. Here we go. And then I want dy dx. And so I get 1 divided by 2 to the y natural log of 2. And dy dx is equal to 1 over what's 2 to the power y? 2 to the power y is equal to x. 1 over x, natural log of 2. So to me, that's not super shocking. We get that form. If you have natural log, the derivative of natural log is 1 over the input. And so we still get 1 over the input, something awfully similar. But on the right-hand side, there's another way to do that. So if you know logarithm rules, let's think you do, you can rewrite log base 2 of x is natural log of x over natural log of 2. And then, well, how am I saying this? I'm saying this is 1 over natural log of 2 multiplied by natural log of x, because 1 over natural log of 2 is a constant. And so, in this case, dy dx is going to be, well, 1 is going to stay there, natural log of 2 is going to stay there. That's all a constant. I just get to ignore that. And the derivative of natural log of x is 1 over x. So we get the same thing two different ways. So we can just prove that rule two ways. Let's go through this way first. Well, log base a of x is natural log of x over natural log of a. So you could say, well, dy dx is going to be 1 over natural log of a, that's constant, times the derivative of natural log of x, 1 over x. Or we could do everything the way we did before. Take a to the power of y is equal to a to the power of log base a of x. A to the power of y is equal to x. Derivative of a to the power y is a to the power y natural log of a times the derivative of that input, dy dx, and the derivative of x is 1. dy dx is 1 over a to the power of y natural log of a, and dy dx is 1 over what's a to the power of y? X. Natural log of a. So there's your rule. And that's all.